Alright, this is part 3 of a lesson about quadratic functions. In this video we will focus on solving a real-world problem involving a quadratic function, a rock being dropped from a building. That probably won't take the whole video, so we will probably solve some quadratic equations, but we'll see how long it takes to do this word problem. A rock is dropped from the top of a tall building 382 feet high. The path in feet is given by this function right here. How long after the rock is thrown is it 100 from the ground? They should have said feet. 100 feet from the ground. Solve by taking the square root. Okay, if we want it to be a height of 100 feet from the ground, okay, that means, see, this function is a function for height. So by giving us 100 feet from the ground, they're giving us a height. Alright, the height is 100. Okay, so that means we're going to have to substitute 100 in for the height. So that means that 100 should equal negative 16 t squared plus 382. Alright, that's fine. So we're going to solve this by taking the square root. So we can get t squared by itself. We can do that by subtracting 382 from both sides. Okay, that's going to make this negative 282 is equal to negative 16t squared. Okay, to get that t by itself, we should divide both sides by negative 16. Alright, these will cancel out. So on the right hand side I now have t squared. So negative 282 divided by negative 16. I know a negative divided by a negative is a positive, so I will just worry about 282 divided by 16. Okay, that is 141 over 8, which is 17.625. You know what? I think I'll leave it as a fraction for a minute. So 141 over 8. Leave it like that just for a minute. Okay. I mean, it doesn't really matter. But how do we unsquare things to get this t by itself? We take the square root of both sides. So we need the square root of 141 over 8 to get this time. Alright, so the square root of 141 over 8. That is, and now we have no choice but to round. Let's do 2 decimal places, so 4.12. Got to round up. Is that right? Yeah, 4.12. Okay, so that is what they asked us for. How long after the rock is thrown will it reach this particular height? So it will take 4.12 seconds. So that is the answer to the question. Okay, so that didn't take very long. and we solved a quadratic equation to do it. So let's move on and solve some more quadratic equations. Alright, number 17. We need to solve the quadratic equation, and they're telling us what to do right here. So even though it says using the best method, I guess they're telling us what the best method is. So we're going to do this one by factoring. Now, just like we practiced before, first we look to see, is there a common factor? Nope. So we move on. We move on to binomial times a binomial. 3x squared can only be 3x times x. 6 is either going to be 2 times 3 or 1 times 6. Okay. As I try the 2 times 3, I will be careful not to put the 3 here. Alright, if I put 3 here, say if I did 3 times 2 like that, see the GCF? That would make a common factor of 3. So if there is no common factor in the original problem, there should never be a common factor inside the parentheses. So don't waste your time on that. So we will try 2 times 3. Now inner plus outer must equal middle. Inner, I have 2x. Outer, I have 9x. I can make 11, but that's it. And like I said, I won't even try it the other way because there shouldn't be a GCF. So the 2 times 3 didn't work. So let's go back and do the 1 times 6 option. Alright, if I do 1 times 6, inner I have 1x, outer I have 18. Alright, the middle is negative 17x, that's what I'm trying to get. I can choose the signs to make negative 17x. If I had a positive 1x and a negative 18, that would make negative 17. Okay, so there's my positive 1, and a negative here would make negative 18. Always check to make sure you're getting the right sign on the last number. So negative 6. Positive 1 times negative 6 is negative 6, so we're good. Okay, but see the equal sign and the word solve? These are the clues that let us know that we're not finished. We're not just factoring, we are solving. So we need to find out what x is. So the way we will do that is by taking these factors. If two factors are equal to 0, then the possible solutions come from setting these factors equal to 0. So 3x plus 1 might equal 0, or x minus 6 could equal 0. On this one, if I subtract 1 from both sides, I have 3x equals negative 1. So then I divide both sides by 3, and I get x equals negative 1/3. So that's one solution. This side is simpler. I add 6 to both sides, and I get x equals 6. So those are the two solutions for number 17. Alright, number 18. We're going to solve this by taking square roots. That's a big hint. Many students have trouble with this. They want to distribute, and they don't understand that you can't distribute when it's being squared. So usually I try to help them by asking them, what would you do if instead of parentheses, what if it was 2q squared plus 10 equals 24? Or even simpler, forget about the squared for a minute. What if I just had 2q plus 10 equals 24? What would you do? What would be your first two steps? And then almost all students can tell me, well, first I would subtract 10, then I would divide by 2. So guess what? Even though we have parentheses, that doesn't change it. It's sort of like the parentheses are the q of this problem, because we have to get the parentheses by themselves. So it is like having 2q plus 10 equals 24. So we are going to subtract 10 and then divide by 2, just like this. So like I said, if we subtract 10 from both sides, and I'll recopy this, so I have 2 times x minus 3 squared is equal to 14. Then I need to divide both sides by 2 to take care of the 2. Okay, so these 2's will cancel out. So now I have x minus 3 squared is equal to 7. Okay, so in order to unsquare this, we need to take the square root of both sides. So that's what we'll do. We'll do the square root and square root. Now be careful. Here's another common mistake. When you're solving an equation and you take the square root of both sides, the solution could be positive or negative. So you always have to put plus or minus like that. So that will unsquare the parentheses. So now I have x minus 3 equals plus or minus radical 7. So one more step. We got to get x by itself. We will add 3 to both sides, but we will put it in the front right there. So that's going to give us x equals 3 plus or minus radical 7. Okay, so that is the answer. Whoops. Please understand that this really means two solutions, 3 plus radical 7 or 3 minus radical 7. That's what that really means. Alright, number 19, solving by completing the square. This is something that students tend to forget how to do. So I'm going to show you how to do this, but please make sure you put your pencils down. Do not copy me as I do the problem. Watch how I do it, and then when I'm done, completely done, go back and do this entire problem by yourself from start to finish. Alright, if you can't remember it for 5 minutes, you don't know it. Alright, completing the square. This is the one where the number here has to be a very special number, and guess what? 12 ain't it. So we need to add 12 to both sides to get it out of the way. So that's going to give us x squared plus 4x, leave a space here, and that's equal to 12. Now the special number that completes the square, we get that by doing half of the middle and squaring that. Okay, so what is half of 4? Half of 4 is 2, and then 2 squared is 4. Okay, so half the middle squared, that's what I always say. Now, common mistake is to forget to balance it out by putting the same thing on the other side of the equation. You can't just take something that was equal. The blue part, x squared plus 4x equals 12, they were equal. If you put plus 4 on the left side, they weren't equal anymore. The left side was 4 too many. So you had to add 4 to the right side to keep the equation balanced. Okay, now the point of picking that special number is because this will always factor in a special way. It will always factor as the same thing twice. So of course x squared is x times x, 4 is 2 times 2. So plus and plus. That's how this factors down. Now, because it factors as the same thing twice, we can write it this way: x plus 2 squared is equal to 16. Alright? Now, to unsquare the parentheses, we can use our square root. So we'll take the square root of both sides. Don't forget your plus or minus. Okay, that's going to give us x plus 2 is equal to plus or minus 4. Okay, now I would subtract 2 from both sides and put it in the front before the plus or minus 4. Okay, now I'm actually going to take this and put it up over here. So that gives us x equals -2 plus or minus 4. We can't leave it like this, alright, because these numbers can actually be added and subtracted. So we have to go ahead and break this down separately. So this means x equals -2 plus 4, or x equals -2 minus 4. Okay, there's your plus or minus from the plus or minus. So this gives me x is equal to 2, and -2 minus 4 is -6. So x equals -6. Alright, now this particular one could have been factored. But for one thing, if they tell you to do it by completing the square, to get credit you have to do it the way they said. You could factor to check your answer if you wanted to. But also, this method works on many problems that are unfactorable. So don't be thinking, oh, I can just forget this method and just factor. No, there's lots of problems that don't factor, so you're going to need this method. Alright, we have plenty more equations to solve, but I'm going to go ahead and stop this video here, and we will continue solving quadratic equations on part 4 of our lesson. Go look for part 4. I will see you on the next video.